All right, so we are going to do Chapter 5 slightly out of order. The reason is because if we look at Section 5.4, 5.4 we're talking more about empirical probabilities. So by grouping these two sections together, we can go through and just kind of discuss our empirical probabilities first, and then after we're done with this section in Section 5.2 and 5.3, we're going to focus more on our theoretical probabilities. So in this section, we will use empirical probabilities to estimate and to verify theoretical probabilities. So if we were to set up a simulation, what we see here is a list of 7 steps. Right? So step 1, identify the random action and the probability of a successful outcome. Step 2, determine how we're going to simulate this random action. Step 3, determine the event we are interested in. Right? Number 4, explain how you would simulate one trial. Number 5, carry out a trial and record whether or not the event you are interested in occurred. Number 6, repeat this trial many times. For the most part, if we were doing something where we were looking for more accurate statistical information, we would want at least 100 trials repeated. However, in the simulation that we're going to do on the next page, we're just going to pick 10. And the only reason we're just going to pick 10 is just for time saving. But generally speaking, if we are thinking about a simulation, we want a lot of trials. Right? So we want closer to 100 trials rather than what we're going to do. The number of times your event occurred divided by the number of trials is your empirical probability. All right, so we're going to take a look at an example on the next page, and this is going to walk us through all of our different steps. Right, so use a simulation to find the probability that a fair 6-sided die will land with the 6 showing up. Do 10 trials using the random numbers below. What is the empirical probability of getting a 6? So again, we're just going to do 10 trials instead of 100, but this should at least give us an idea of kind of the process that we go through. All right, so step 1, identify the random action and the probability of successful outcome. All right, so the random action is throwing the die. And the theoretical probability of a successful outcome, if we think about this on a fair die, a fair 6-sided die, we have exactly one number 6 on there. So 1 out of 6 gives us 0.167 or 16.7% if we were to write that as a percent. Now you determine how to simulate this random action. We will simulate this random action by using the digits in the random number table to represent the roll of the die. Right, so our die only has 6 sides. So that means we are going to use the digits 1, 2, 3, 4, 5, and 6. And we're going to ignore the digits 0, 7, 8, and 9 because they're not useful for a 6-sided die. Determine the event you are interested in. Right, what we are interested in, whether we see a 6, in a single toss. Right, that's what we are interested in. Explain how we would simulate one trial. We are going to read a single digit. So a trial consists of reading a single digit in the table. We're going to carry out a trial, and then we're actually going to repeat it a bunch of times, and we're actually going to use the numbers above to go through and help us come up with our different rolls. So let's look back up at this number, our random number table rows. Remember that we can't use anything that's outside of 1 through 6. So I'm going to go through and start by crossing off, at least in our first line, anything that we can't use. So I'm crossing off my 0s, my 9s, my 8s, and my 7s. Right? And if you want to, depending on how big you have, you could go through and eliminate stuff in other rows, we don't really need to. This should be enough to give us 10 rolls. But if we were continuing on, again, anything that's a 0, 7, 8, or 9, we can't use. So we're going to skip that. Okay, so the numbers that we are going to use for our rolls. And we're going to have 4, 4, and 3. So I'm going to go down to the bottom and put 4, 4, and 3. And then we're going to come back up top here. We're going to have 5, 6, 2, and 1 from that next group. So 5, 6, 2, and 1. And then we just need 3 more. So we're going to have 4, 3, and 5. All right, so from our simulation, again, we just used the digits 1 through 6, and we just started at the beginning in this case and used the first ones. Again, we got rid of anything that was a 0, 7, or 8, or 9, because that didn't represent a number on our 6-sided die. All right, so did our event happen? All right, our event is rolling a 6. So in our 5th roll, we got a 6, but that was our only one. So in our experiment, the empirical probability of a successful outcome is 1 out of 10, which is 10%, which is, if we look back up to our theoretical probability, significantly smaller than our 16.7%. So if you're asked to go through and do a simulation, again, whatever you're looking for, again, this was a very short simulation. Usually we do a lot more trials. We want to do at least 100 trials, but this gives us an idea kind of how we go through, we carry out that experiment, and then how we get our empirical probability then when we are finished. Right, we had exactly one positive outcome, one outcome of the event that we were looking for out of 10 total, and we divided to find that percent.